So if you go into the Pro Tools section, this is your main menu. We're going to choose the Diagnostic Intelligence Report. This form is designed to help technicians understand what's happening inside of a system on the refrigeration cycle primarily. So we start at the top. It can be a form set for cooling, heating, a full inspection, if it's an AC with a furnace, a heat pump, and so on. From here, it gives you the option to save the readings locally, to download the file of your readings, or to upload it in case you want to recall it. And all the data stays in your browser until you click New Clear Form. So in this case, I started populating some of the information. Of course, the age of the system matters, and some of them are just naming conventions like area served, name of the technician, and so on. Type of refrigerant is very important, metering device, and if you suspect of anything known with contaminating refrigerant, so we'll put none unknown or none known, for example. As you start entering readings, it starts grading them. For example, if I was to enter 260 volts, it'll flag it. If I tell it, well, it's actually 245, in this case, it goes away. This one right here, contactor needing attention, is because I put other things in this form already. So it asks for my voltage drop, my contactor condition. For example, if it's minor pitting, if it's like new, so I'll leave it at minor pitting. My capacitor for the compressor is under a load, so I put 45, my amperage and the voltage, and it tells you what the capacitor is doing. The capacitor fan motor, this one's not under a load, so you just enter what you read with your meter. Voltage, the more information that you start giving it, it starts populating these little windows here with more information. You can check things to tell it it's good, it's monitored, it's an issue, and so on. You just start clicking things. And the more information, again, the more information you give it, the better it is. If I tell it monitor because the pad is not level, the line set insulation, clearances doesn't have a lot of clearances, my disconnect condition, and so on. So you just start, adding a lot of these. So let's say I said monitor, and good. Then you enter your readings as well. So in this case, I'm going to put my suction pressure. Let's say that I have 134. I have a liquid pressure of 345. We're at 85 degrees. It requires a 10 degree subcool. My discharge air is 97 coming on top of the condenser. My suction line temperature, for example, is 71 degrees. My liquid line temperature, we're going to put it at, let's say, 89 degrees. And we'll just repeat those two, 71 and 89. So it already starts telling you, again, more information, the line set length as well. And you just keep on going. Just keep going with the rest of the readings. Start entering duct seal and all that stuff, your static pressure, your return, your supply, everything. Then you just generate full analysis. If we start at the top, it runs the tool through the refrigeration cycle first. Then it tells you compressor wear failure. This is not telling you that the compressor is bad. It's telling you that one of the things that are happening is your compressor is not compressing correctly, but it's giving you confidence of 46%. So this is not like telling you condemn the compressor. It's telling you this is what's happening right now. And this is what could be causing it. So it starts bringing it down through the refrigerant cycle check, your compressor, your condenser fan motor. It calls out for the repairs as well that it detected. Then it gives you a dashboard that's telling you where everything stands from the readings that you enter. So the more that you enter readings, the better it works. So this is the core of this tool, this 6-question diagnostic. So it goes through, does the system have enough refrigerant? Is it releasing enough refrigerant? Is it condensing correctly? Is it absorbing enough heat from the house? Is the refrigerant boiling correctly? And does it have enough returning to your outdoor system? Remember that the core or the function of an air conditioning system is to transfer heat from one location to another. So by analyzing these 6 questions, the tool will know what to do. But at the same time, sometimes some of these questions are not 100% telling you the whole story. So one of them might tell you, it looks like this can cause or is a sign of a TXV underfeeding. Then the next question says this is a cause or sign that your TXV is overfeeding. So the cross analysis breaks those two apart and it points you in the right direction. So this tool will help you understand what's happening with the system. Now the next part is for your customer. It gives them a rating right here where the system stands compared to a healthy system. And it's all explained in non-technical words. What's happening to the compressor? Why do you need your condenser fan motor replaced? In case it was a capacitor, it doesn't have an indoor air quality device. You can download this as a PDF and share it with your customer. Then here's another cool part of this tool, the logic analyzer. So let's say after I saw all the readings and everything, I suspect that the system is having a TXB that's restricted. I click on that and it tells you, well, you think that, but these are the things that push back against it. Well, I think it's actually overfeeding. Well, this is why yes and no. I think it's low on refrigerant. Well, this is why yes and no. So it has a lot of these options that you can just compare. So the compressor worn out, low compression, this is why. Now, another thing that I want to show you, if you go back into our dashboard for tools, you have, for example, your airflow and CFM diagnostic tool pack. This is very cool. Once you go into here, this tool has, for example, a room by room supply checker, a return checker, and a flex ductulator. So for example, if I go into my room by room and keep in mind, everything has an explanation and it's designed to help you as a technician understand what's going on. So if I open up the room by room, this one, for example, I'll click reset all rooms. And I will tell it this is a system that's a 3-ton system set to 300 CFM per ton. My ductwork is, it's okay, 4% compression. And I need to add a room. So this room is, for example, measures 20 by 15 by 9. And it's a master suite. No complaint. It has 2 windows. They're both facing east. They're the standard modern. They are large windows. So it tells you, okay, you need 310 CFM approximately. Now this is a small block load calculator in here. It's not taking into account insulation and all that other stuff. So this is just more like a base tool right here. So once I select that it's 6-inch and it's 2 runs, the length is 25 feet. It's telling you, okay, it's good, but look at your air velocity, meaning that the vent is going to be very loud. So what if I change it to 2/7? It's telling you, okay, it's good. And now you're at 580 feet per minute. But it's also designed to catch if your ductwork is oversized. So what if I tell it that I want to put 2/10? It says, okay, you're good. Your velocity is down, but look at your warnings. So this is one way. So let's say I put it at 2/7. Another cool thing is it accounts for the tonnage, CFM, and it's telling you good. You're using 310 in one room, but you still have more to use. So I'll put add another room, and this is going to be my living room. And let's say that this is 20 by 40, large living room. And it has 4 windows facing southeast, standard, and they are extra large. And it has four ducts, 7-inch. Now it's telling you it needs 960, but again, look at your feet per minute. So what if I tell it, well, I'm going to add an extra run? It's still not there. Well, I'm going to need another one. So this is 6 runs, or if you keep it at 4 and upgrade them to an 8, now you're there. So this is another way of using this tool. For example, it also has a return checker. For example, if it's again a 3-ton system for 100 CFM, and I tell it it's an upload with a return grill, I enter the measurements, and it tells me that return grill can only carry this much. So it's only providing 60% of what my system needs. So what if I cut another hole and add another return grill? Now you're talking. Now it's 1444. It's 120%. So this is another way of using it. Another way is if I cancel this and I tell it, well, it's a horizontal with a duct and it has a 16 inch. For a 3 ton, it's telling you you have 977 out of 1200. So you need to either increase this or add another return. Best thing is to add another return. If I add another 16, I did it wrong. It's a round duct. If it's a 12, it's still good. If I go with a 10, still there. But why would you add a 10-inch return? I would keep it at 12. So this is another way of using this tool, for example. You also have your, of course, a report to print of everything that you're doing in case you want to keep it for your records. It has a flex ductilator. This one you'll select if you're working with return or supply. And you adjust your parameters here and just use the sliders. If I exceed the 10 right here, it disappeared. And it's telling you why. It's telling you, well, I'm recommending that you split, and these are some of the recommendations. It also has a branch analyzer. So this branch analyzer comes in very handy. For example, I'll tell it I'm working with supply rooms. I'm trying to provide, what if I told it I'm trying to provide, for example, 380 CFM to an area of the house, and I'm trying to run it off of a 9-inch duct. Right away, it tells me that branch is at 309 capacity with an 860 under what I put. I'm going to use 0.08. It's slightly compressed at my 4%. So what if I tell it, okay, I'll go with a 10. Your 10 says, okay, velocity drops, capacity 382, so you're good. Now add your branches. So I'm going to drop for example, an 8-inch duct, and the intention is to provide 140 CFM on 25 run. Then I'll add another 8-inch at 140 CFM. And just to make sure that they can carry that, you can go back to your ductilator. We set it at 0.08, 25 feet. And I'll just use my slider. And yes, definitely an 8-inch can carry that. So we can even put it at 150 if I want it. So let's say that we'll max it out to 150. And I'll add another branch that goes into a closet, no, a bathroom. Then I needed to carry 90, and I'll add a 5 to carry 60 for a closet. And again, this is 25. This is going to be 30, and this is going to be 30. Now, the tool is saying that we're exceeding. We're demanding more than what the duct can carry on this. So if you notice, we have 300, 390, 400. So this would not be enough for this example. So either I give it less air or I increase my duct. So in this case, this would have to go up to a 12 in order for it to support. But I would need to rerun the whole thing, because if I give it a 12, it has a capacity for 550. So then I would have to tell it this is 550. But in reality, we were trying to run, my total was 440. So we will set it at 440 at 12-inch duct, has a capacity of 550. And now everything checks out good. My feet per minute is right there, even though my feet per minute here is dropping a little bit too much. But that is how you use this tool, for example. And all of this is inside of our Pro Tools. So it also has a compressor diagnostic and electrical assistant. This one will actually help you understand what wire size do I need when I install a system. So with this tool, what you can do is just find out if your wire size is correct. It has two options. You can go through the whole thing, steps 1, 2, 3, 4, or you can just go straight to number 5. But to use 5, you at least need to enter stuff on number 2. Anything that you do not understand, it gives you a little bubble where you can highlight, and it gives you recommendations. In this case, I'm going to tell it the type of equipment. I'm setting up a condenser heat pump. My minimum ampacity is 40. My max is 55. My supply voltage is 240 single phase. From here, I can just go directly, unless I'm going to check an existing configuration. So I'll check this, and it currently has a 10 gauge wire, and it's copper. It's rated at 75, and the existing breaker size is a 60. And I'll just put calculate, and it tells you you need an 8, not a 6, not a 10. And your max is this, so it tells you why it will work, why it not. Existing wire check, it can only take up to 35 with an equipment MCA at 40 and an existing breaker of 60. So if I go back to my equipment and I tell it, well, I don't want to do the quick check. Tell me what I need. So in this case, we can just start all over or just continue. So continue here. I'm going to tell it it's a copper. Wire insulation is 75. It's in the attic, and it's a 2 to 3 wire conductor. Now the distance between my main panel and my disconnect, it's going to the condenser. So let's say it's 65 feet. I'm not going to put the disconnect to the unit for now. And the voltage drop, what do I need to put? Well, it says my recommended, so we'll go with 3% recommended. Power factor, it explains it to you. I'll just put modern variable speed, or it's an actual standard scroll system. Put that. And we're going to uncheck this and calculate. And it tells me, well, you're going to need 8-inch wire with these specs as well. Now it's giving you a little warning here, but this is to help you understand what's going on. What wire size do you need? You also have a training guide that explains every single thing to you with this electrical tool as well. And you also have a quick reference chart as well. So you can go through it here. Now remember, these are tools designed by an HVAC technician for HVAC technicians, because when you're in the field, a lot of the times you don't have someone to tell you what to do, or sometimes you don't have who to call. And these tools are designed to not only help you understand what you need to do, but also guide you, also teach you the why behind it. So a lot of these great tools at Innovatek1.com are designed with that purpose. So that's why I definitely encourage you to try them out and give us feedback.